Okay, welcome back. Hopefully everyone had a good, productive weekend, and you're all healthy and still dealing with all of our sheltering and social distancing and all that type of stuff. So hopefully in the next few weeks we'll all get back to a little bit more of a normal. Okay. So last time we learned how to add and subtract polynomials, and we also learned how to multiply polynomials. So now we're going to learn how to multiply polynomials again, but with some special cases. All right, so that's what this section's all about. So 4.6 is on special products. Okay. All right, special products. So products, remember, that means multiplication. Okay? So the first thing that we're going to learn how to do excuse me, is to square a binomial. All right? And you could either look at this as the sum or the difference. So I'll do both. So here's a binomial, a plus b, remember, two terms, and then we're going to square it. Okay? Now, recall our definition for exponential notation. We can expand this out as, or from exponential notation, we can expand it out in standard notation as a plus b times a plus b, right? And then now you know how to deal with this. This is just using FOIL or the distributive law. So let's do that. A times a, and that's going to be a squared, right? And then we have a times b, which is going to be ab. And then we have b times a. So we can write that as ba or ab. It makes no difference, right? The order doesn't matter. And then b times b is b squared. So we haven't done anything special yet. We're just going to simplify this and by collecting these like terms. So this is a squared plus, well, we have ab and ab, that gives us two ab's, and then plus b squared. Okay? So a plus b raised to the second power will always be this particular pattern right here. A squared plus 2ab plus b squared. And you might think, well, what's the big deal? I can always use the distributive law and get this answer. Well, there's actually a shortcut, and this is where the special product comes in, okay? So let's look at this pattern here. I'm going to call this a plus b. So I'm going to call the a term the first term, and then I'll call the b the second term, or I could also call it the last. A lot of times I'll refer it to the last term. All right? So look at the pattern. The first term over here, okay, as the result, so I'm highlighting it. Notice the first term is squared, okay? And then notice that the first and second term, right here, the first and second term are multiplied together, so the a times the b are multiplied together, and then it's multiplied by 2. So what that means is you're doubling the product of the first and the second term, or the first and the last term, right? You're doubling it. Anytime you multiply by 2, you double it, okay? And then this b squared, okay, that's the second term, or the last term is just being squared, okay? So the pattern, all right, listen to what I'm saying. When you have a binomial squared, so a plus b squared or a minus b squared, it works the same. You're going to square the first term. You're going to multiply the first and second terms together, or the two inside terms together. You can say that, inside meaning inside the brackets. Then you double that product, and then you square the second term, or you square the last term. Okay? So let's repeat that. For a binomial squared, you square the first term, multiply the two terms together on the inside, the first and second term, double it, and then you square the last term, or you square the second term. Okay? So let's do that just for a minus b squared. So let's just do the shortcut. We square the first term, so that's a squared. We're going to multiply a times b together, the first and second term, so that's ab. Then we're going to double it. We put the 2 there, and then of course it subtracts, so I'm going to put the minus sign there. And then, you know, when we square a negative, it becomes positive. So you square the last term, it's going to be b squared. And that is the special product. Because what's going to happen is when you go to more advanced classes, and then a lot of times what I'll do is I'll just not go the longhand route. I'm just going to just write down the answer. First term squared, multiply the two inside terms together, square, double it, and then square the last term. Okay? So let me write this out for you. Okay? So when squaring a binomial, alright, what you're going to do is you're going to square the first term, okay, then you're going to multiply the two terms together, the two inside terms, so multiply the two terms together. Okay, that's the, you know, the A and the B, all right, and double it. The doubling means you're just multiplying it by 2, okay? And then, so what you'll get, you get 2ab, right? And when you square the first term, let me put this right here, you get a squared, right? Okay, so we did the first one. You squared the first, you get a squared. You multiplied the first and the second, or the two inside terms together, you get 2ab, all right? And then finally, last step we know, is you're going to square the second term, which you can also call the last term, okay? And what do you get? You get b squared, all right? So the only thing that you have to realize is when it's a plus b squared, you're going to get plus 2ab. When it's a minus b squared, you're going to get the minus 2ab. Okay? So let's practice some of those. Okay? And it just takes practice, but you just got to get the pattern. It'll be very easy. So m minus 6 squared. All right, let's talk this out. Square the first term, m squared. Let's multiply these two terms together. So that's basically minus 6 times n. So what's minus 6 times m? It's minus 6m. And I'll write this out, but then I'm going to double it. So I put that 2 there, okay? So you'll start to be able to do this in your head. M times minus 6 is minus 6m, double it, you get minus 12m, right? Then I'm going to square the last, so you're always going to get a plus, so minus 6 squared is 36. So you end up with m squared minus 12m plus 36. Okay? Let's do another one. C squared plus D squared. Okay? So I'm going to square the first, so I'll actually write this out. So C squared, then I'm going to square it. Right? Then I'm going to multiply the C squared times the D squared, right? Okay? And then I multiply that by 2, so I'm doubling it. And then I square the last, so that's D squared squared. So we end up with C to the 4th plus 2C squared D squared plus D to the 4th power. Remember, when you raise one power to another, you multiply. So 2 times 2 is 4. 2 times 2 is 4. Okay? All right, let's throw a fraction in one of these. Excuse me. These cough from allergies. Okay, so let's do this one. This is y subtract 5/3 and then squared. Okay? So again, square the first, y squared. Multiply the two terms together. So that's going to be a minus 5/3 times y, but then I have to double it, so I'm going to multiply by 2. And then I square the last. So minus 5/3 squared. Well, we know it's always going to be positive. So 5 squared is 25. And 3 squared is 9. Okay, so all I did was I just squared the minus 5/3. Okay? So that's y squared minus, okay, well, this is like 2 over 1. So 5 times 2 is 10, so it's minus 10 thirds y. Okay. And that's plus 25 ninths. Okay? All right. So that takes care of one of our special products, which is going to be just a binomial squared, right? Okay. Let's look at another special product, and that's going to be multiplying the sum and difference of two terms. Let me go back for a second. I have a thought in my head that I usually say to my students in class, and just keep repeating this whole thing to yourself when you're working with a binomial squared. Okay, just keep saying it. Square the first term. Multiply the two terms together, then double it. Square the last term, or square the second term. Okay, just keep saying that. Square the first term. Multiply the two inside terms together, then double it. Square the last term. Okay? Once you get that in your head, it'll be just like second nature when you're squaring these binomials out. Okay? Because what's going to happen, let me just, I'll do it here, then I'll erase it. You know, eventually, instructor's just going to have this on the board and say, okay, well, that's 3x squared, I'll just do 3x, let me rewrite this, 3x minus y, okay, squared. And they're going to go, well, that's 9x squared minus 6xy plus y squared. And you're going to go, wait, well, how'd you do that? How'd you do that? I don't get it. Well, I did is I squared the first. I multiplied these two together and got minus 3xy, double it. So you get minus 6xy, and then you square the last. Okay? That's why I'm telling you, you really need to learn the pattern, because that's how fast it's going to eventually be for you. Okay? All right. So let's go ahead and work out our second special product, and that's multiplying the sum and difference of two terms. Well, just what it says. The sum of two terms times the difference of two terms. There we go, a plus b times a minus b. So again, let's use our distributive law. A times a is a squared. A times minus b is minus ab. B times a is ba or ab. We could write it as ab, right? And then b times b, or b times a negative b, is minus b squared. Now notice these two cancel, and they will always cancel out. Always. That's if you have the sum and difference of two terms. Okay? So what we end up with is just a squared minus b squared. Right? So there's also a pattern here. Okay? Let's take a look at the pattern. Well, that's just the first term squared and then the second term squared. Okay, so what am I talking about here? Let's just look at this. The first term is squared, and the second term is squared, and then you just put a negative sign in between them, right here. Right there. Okay? It's a real easy pattern to remember. Okay? So let me write this down. It's the first term squared, excuse me, minus the second term squared. All right? All right, let's do it. X minus 5 times x plus, times x plus 5. All right, it only works for these situations. So let's do the first, the shortcut, okay? The first term, so here's the first, here's the second, right? Just like that, okay? Well, what's x squared? Well, it's x to the second power, right? What's negative, what's 5 squared? That's 25. And then you just put your minus sign there. X squared minus 25, and you're done. Okay? You don't need to do this long process of the distributive law. Well, x times x is x squared. X times 5 is 5x. Minus 5 times x is minus 5x. And minus 5 times 5 is minus 25. And these cancel out, and what do you get? X squared minus 25. Same thing as we got right here. All right? So we always know that these middle terms are going to cancel. So just use that shortcut. Square the first term, square the second term, and put a negative sign in between them, or a subtraction sign, right? Let's do another one. Let's throw in this one. How about x squared plus 1 times x squared minus 1? Okay? Well, we're going to square the first term. Again, just identify this is the first, this is the second. So we're going to square x squared. We're going to square 1, and we're going to put a minus sign in between. So this is just x to the fourth minus 1. Done. How about this one? 2x plus 5 times 2x minus 5. Square the first term. So let's just do this in our head. 2x squared is going to be 4x squared. Or sorry, 2x raised to the second power, I should say it like that, is 4x squared. Okay? Square the 5, you get 25. Put your minus sign in between. And that's it. Okay? Let's do one with a fraction. M plus 4/5 times m minus 4/5. Okay? So let's square the m squared. Square the 4/5. So we can do this to the side here. So 4/5 squared is going to be 16 over 25, right? You square the 4, you square the 5. And then you put your subtraction symbol there. And that's it. Okay? All right. So that's your second special product. Now, let me just make a comment here. If for some reason you're on an exam and you don't feel real confident that you're doing the right pattern, just go back to basics. Use the distributive law and verify your result. That's all that you have to do. Okay? Okay. You might say, well, what about if we get something like we've already done a binomial squared. You might say, well, what if it's a binomial cubed or a binomial to the 4th power or any higher power? Well, there's actually a way to do that, and there is a shortcut way, but you won't learn that until you get into like a college algebra class. Okay? So right now, to deal with, a binomial raised to the nth power, we're just going to use basic algebra. Just use the tools that we know right now. But later on, you will learn how to expand things like a plus b to the 3rd power, a plus b to the 4th power, and so on. It's called the binomial theorem, all right? So, and this could be plus or minus, right? Doesn't have to be just plus. Okay, but for now, we're just going to use basic algebra. So, for example, let's just say you were asked to do x minus 2 cubed. So, I want to simplify x minus 2 cubed. Okay? Well, this is simply going to be done by going back to our basics. Well, how do you expand this out? Well, this is just x minus 2 to the 2nd power, right, times x minus 2. We can write it like that, okay? I mean, we could have written x minus 2 squared as x minus 2 times x minus 2, but we're going to use our shortcut that we know now how to do a binomial squared, okay? And then we're going to get that result and then multiply it by this. So remember the pattern, square the first, so that's x squared. Multiply the first and second term together. All right, so that's minus 2x, but we're going to double it, so a minus 2x becomes what? A minus 4x, right? Okay, and then we're going to square the last, so minus 2 squared is just going to be plus 4. All right? But then we have our x minus 2. You have to bring that down. Okay, so now we're back to a little review. We're just going to use the distributive law. So let's see, x squared times x is x cubed. X squared times minus 2 is a minus 2x squared. Minus 4x times x is minus 4x squared. Minus 4x times minus 2 is 8x. 4 times x is 4x. And 4 times minus 2 is minus 8. Okay? So we just need to combine like terms. Let's see what we have here. X cubed, so I'm done with that. Looks like here's our squared term. So we have minus 6x squared, right? Minus 2x squared minus 4x squared. And then these are like terms, so 8x plus 4x is going to be 12x, and then subtract 8. Okay? And this is written in descending order. So let's see if you can follow this same process. I'd like you to work this problem out, x plus 1 to the 4th power. Okay? So pause your video, work this out, and see if you can get the same result. All right? Okay, so let's work this out. How about if I went, well, that's just x plus 1 to the 2nd power times x plus 1 to the 2nd power. That's the most efficient way to do this. Okay? So we have the product of two binomial squareds. Okay, so the first one is square the first, x squared. Multiply the two inside terms together, so 1 times x is 1x, double it, you get 2x. And then 1 squared is 1. And then you're going to get the exact same thing right here. Okay. Now we have the distributive law. So we'd work all this out, and I'm just going to do that real quick here. So let's see, that's going to be x squared, or sorry, x to the 4th power, bad. X squared times x squared is x to the 4th. Then x squared times 2x is going to be 2x cubed. Then x squared times 1 is going to be x squared. Then 2x times x squared is 2x cubed. Then 2x times 2x is 4x squared. Then 2x times 1 is going to be 2x. And then, of course, 1 times each one of these terms, you get the same thing back. So that's just going to be x squared plus 2x plus 1. Okay? And now we have to go through of combining like terms. So there is no 4th power term besides x to the 4th. So that's done. So let's see. We have a 2x cubed, and a 2x cubed. So that's going to be 4x cubed. Okay. Then we have an x squared, a 4x squared, and another x squared. So that looks like that's going to be 6x squared. Okay. Then we have a 2x and a 2x, so that gives us 4x. And then the last one here is 1. So I should have canceled these out as I went. So let's do that. And then our last one is just the 1. Okay? Okay, and that's our final result. And this is also written in descending order. Okay? Okay, now we're going to look at order of operations with polynomials. So let me write this down. I just inserted this text. So let's do, this is for order of operations for polynomials. All right, so let's just read this together. Okay. Go back up here. All right, so it says, oops. Here we go. Okay. If possible, simplify any polynomials within parentheses by combining like terms. That makes sense. Square or expand all polynomials raised to powers, where we just learned how to do that, using the FOIL method or a special product rule, right? The sum of two binomials or the difference of two binomials squared. So the sum of two binomials squared or the difference of two binomials squared. All right. Then step 3, perform all polynomial multiplications using the distributive property, the FOIL method, or a special product rule, right? The sum and difference of two binomials. And then finally, perform all polynomial additions and subtractions by combining like terms. All right? So it's pretty much the same as our order of operations. Do what's inside parentheses, raise things to powers, do multiplication, and then perform the addition subtraction. We haven't done division yet, so there's no mention of division in this. We will do division on the next section. Okay? So let's do an example. So let's just say this says perform the operation. All right. And let's look at 4b plus 1 squared minus b minus 7 times b plus 7. Okay? Well, this is great because we can follow these rules up here. Well, there's nothing to simplify within any of the parentheses, so we can skip that. But we can use rule number 2. We want to do any type of powers. So this is just a binomial squared. So again, this will equal to the first term squared, so that's 16b squared, right? Then multiplying the two inside to get terms together. Well, 4b times 1 is 4b, and if we double 4b, it becomes 8b. So 8b. And then squaring the 1, you get just 1. Okay? Then we're subtracting. Now this is the thing where you got to watch out for. We're subtracting the result. So we got to put the result in parentheses here, right? If you don't, your answer is going to be incorrect if you don't use those parentheses. So this is just the sum and difference, or the difference in sum in this case, of two binomials. So you're going to square the first, square the second, and put your minus sign there. Okay? And can go to the next step. So that's 16b squared plus 8b plus 1. Okay. The opposite of everything in the parentheses, so that's minus b squared, and then plus 49. Okay. Then we can combine like terms, right? So let's finish this up. So this is a b right here. Looks like a 6, but it's a b. Okay, so 16b squared and negative b squared. So that's going to end up being 15b squared. All right, so I finished those. Then no other b's, so that's 8b. Okay, so that's done. And then 1 plus 49 is 50. Okay, and that's our final result. So we did follow these steps. Let's just go back here. So the first one said simplify any polynomials within parentheses by combining like terms. Well, there was nothing we could simplify within the parentheses. So then we went to raising what's in the parentheses or the polynomial to some power. So we did that. Okay, we raised the 4b plus 1 to the second power. Then it says perform multiplication using the distributive property or a special product. Well, we use the special product on this right here, the difference in sum of two binomials, right? Okay, so we did all that, and then we started combining like terms, right? So right here, step number 4. So we're going to combine like terms by just your adding and subtracting polynomials. So we did that, and then we have our final result right here. Okay? All right, let's try another one. Okay, let's do 3y times y plus 2 minus y subtract 4 to the second power. Okay, we can't simplify anything within the parentheses. We can simplify this, the power, right? Okay, so let's just, I won't do anything here yet. So it's 3y times y plus 2. Subtract, got to put this in parentheses now. Square the first, right? Multiply the 2 inside together, so that's minus 4y. So minus 4 times y is minus 4y. Double it, minus 8y. Then square the minus 4, you get plus 16. Okay? Then we're going to perform any type of multiplication. Well, here it is right here. So it's a monomial times a binomial, nothing special. Just use the distributive law. So that's 3y squared plus 6y. Then we're going to take the opposite of everything in there. So it's minus y squared plus 8y minus 16, right? Then the last step says to collect like terms. Okay? By just doing basic addition and subtraction. So 3y squared minus y squared is going to give us 2y squared. So I cancel those out. 6y plus 8y is 14y. So cancel those out. And, whoops, sorry. Yeah, that's right. 6y plus 8y is 14y. And then the last term is minus 16. Nothing common there, so we're done. That's our final result. Okay? So let's do one more problem. This is kind of interesting. I like to do this problem. So let's say we have like a picture frame. So the center part is basically hollow, and then I'll just shade this. This is like the wood or whatever material of a frame. Okay? And I'm going to put some dimensions on this. I'm going to say this is all the way across is 4x plus 1. Then this little height here is x. And then this distance is 3x minus 2. Okay? And then this distance is 3x plus 2. Okay? And the question would be to find a polynomial that represents the shaded area. Okay? And let's just say all dimensions are in centimeters. Okay? And that's abbreviated CM. Okay? All right, so this is pretty simple. The area of the shaded part, wouldn't that be considered the area of the total, or I should say the total, or the entire rectangle? Okay, subtract the area of the inner rectangle. All right? So you take the area of the complete rectangle, and let me shade this all in. So this would be the complete or the entire rectangle. And if we subtract it from the inner rectangle, what's going to be left is just the area of that shaded part. Okay? So let's do that. The area of the entire rectangle is length times width. So the length times the width. So that's going to be 4x plus 1 times 3x plus 2. Then we're going to subtract the area of the inner, which is just going to be x times 3x minus 2, length times width, right? So now we just simplify this. No special products here at all, so we just have to use the distributive law. So 4x times 3x is 12x squared. 4x times 2 is 8x. 1 times 3x is 3x. And 1 times 2 is 2. So you can also say I used FOIL on here, right? First, then the outside, then the inside, and then the last. Okay? Then subtract, got to put this in parentheses. So x times 3x is 3x squared. X times minus 2 is minus 2x. Okay, so that equals 12x squared. I'll just combine these two right now, plus 11x plus 2, and then take the opposite of everything in the parentheses, so subtract 3x squared plus 2x. So combine like terms again. So let's see, a 12x squared and minus 3x squared, that's going to be 9x squared, right? So I'm done with those. Cancel them out. 11x plus 2x is 13x. Okay, cancel those out, and then what we have left is just the plus 2. And since this is in dimensions of centimeters, when you multiply, or when you're dealing with area, you're going to have an area dimension, so centimeters squared. Okay? Or you could write out centimeters squared. Okay. Oops. Centimeters squared. You could write it like that as well. Alright, so this represents this 9x squared is the polynomial, or 9x squared plus 13x plus 2 is the polynomial that represents the shaded area. Okay? Alright, that concludes section 4.6, which is on special products. So make sure you go through those and memorize the patterns. And then the next section we'll start dealing with is division of polynomials. Okay?